Hello, and welcome to Train Signal. I'm Don Jones, and this is the Basic Queries lesson in the Database Administration Fundamentals course. In this lesson, we'll dive into the most basic and fundamental query in SQL, the SELECT query. We'll start with a simple SELECT FROM query, add a WHERE clause, add sorting with an ORDER BY clause, and then discuss column aliases and naming rules. SELECT is the most basic and probably most used query in the entire SQL language. It's used to retrieve data from a single table, or as a join query, from multiple tables. We'll start by performing some basic queries that select all columns from a table, and then just select specified columns from a table. We'll test these queries in SQL Server Management Studio using the Query Analyzer functionality. Because queries are far more interesting when there are some results to look at, we're going to perform most of these examples with the AdventureWorks database. And we'll just pick a table to play with here. Let's take a look at the person.address. And for my reference, I'm going to expand this so that I can see the column names that are available to me. So let's just do a very simple query to start with. Select star means select all columns. So I'll be getting every single one of those columns from person.address, which is the name of the table. We'll run this by clicking execute, and we got an invalid object name. Person.address doesn't work. Well, why is that? Now, keep in mind, whenever you open SQL Management Studio, it's usually going to default to the master database. And this is just telling me that person.address table doesn't exist in the master database. I actually needed to come up here and make sure I explicitly changed to the AdventureWorks database. Now I should be able to run my query and get some results. So let's change this up a bit. Let's actually specify some of the columns we want to see. Let's grab address line 1, and I can use this IntelliSense pop-up menu to very quickly complete things. Using this also helps make sure I don't accidentally mistype something. So this is just a comma-separated list of the columns I want to get, and when we run it, I get just those columns. Now when you look at SQL Server syntax documentation, you'll often see the language keywords. That's the thing that Query Analyzer here is showing to me in blue text. These will often be capitalized. Object names, like the field names I'm after, the table names, everything else, those will tend to be listed in lowercase, or in this case, they're listed exactly how they show up in the table schema because I let IntelliSense type them for me. In the end, it doesn't matter. SQL Server's command syntax isn't case sensitive, so you can type them however you want. In fact, I'll click undo a few times to put them back that way. I find lowercase a little bit easier to read, so I'll stick with that. It's rare that you'll want to retrieve every single row from a large table, so the WHERE clause lets you specify which rows to retrieve. You'll typically make that specification by using comparison operators to compare the value of some column to a specified value. We'll start with some simple comparisons, and in another lesson expand to more complex ones. Make note, string values get delimited in single quotation marks, as do date and time values. Numbers do not get delimited at all. This is also a good time to consider how you'll visually format the queries in Query Analyzer so that when you're typing them, they're a bit easier to read and edit. Let's go back to SQL Server Management Studio, where we can use the Query Analyzer to work with some WHERE clauses. So before we start adding anything to this query, let's talk a little bit about formatting. Query Analyzer doesn't make you type your entire query onto a single line. It's perfectly acceptable for you to hit enter, and a lot of times this is how you'll see people work their query formatting. You'll notice that it's got this little sort of minus sign with a little line coming out of it, and that tells me that both of these lines are being interpreted as part of the same query. By breaking the query's different components down on different lines, it just makes it a little bit easier for me to read it, to visually interpret it, and if I need to go edit it. I hate having to scroll sideways, so I don't like to type things on one line because I can't see the whole query on one screen when I do that. So now let's go ahead and add our where clause. I'll add it on another line. And I also like to indent each of these lines, and that just, again, gives me some visual indication that they all go together, in addition to this little gray line over here, which is telling me that this is all part of the same query. So let's start by grabbing everybody who is in the city of Paris. Notice that this is a string value, so it has to be delimited within single quotation marks. We'll run that, and that gets me everybody that's in Paris. Now, let's actually narrow that down a little bit more. And postal code equals, now this is a numeric value, so I shouldn't need to put quotation marks around it, 75017. And we'll run that again, and that limits things down a little bit. That also demonstrates the use of the Boolean AND. So you can actually get quite complicated with these query criteria. Let's take that out. Run this again with no query criteria so that we can really see what type of data we have. Maybe we'll go back to selecting all of the columns. Now let's add in something a little bit more complicated. Let's say where city equals BOTHELL and postal code equals 98011. Very important that I spell this right. You'll notice that it's put a little red squiggly mark under Coty because it doesn't recognize that as a valid column because I mistyped it. If I put city in there, and if I had used IntelliSense and let it type city for me, my little red underline eventually does go away. So let's keep going with our query now. Let's add an OR clause. And now we can say where city equals Paris or postal code equals, and I'm just going to scroll down in my results set to get another postal code we can play with. Let's grab 98020. So here's what's going to happen. Every single row that shows up in my results set has to meet this criteria. And that criteria means either this set has to be true or this set has to be true. So there's my OR between those two sets. In order for the first set to be true, the city has to be Bothell and the postal code has to be 98011. The second set can be satisfied by the city being Paris or the postal code being 98020. So let's run this. Conversion failed. So what this is telling me here is that my postal code is actually not a numeric value. Let's go back and just select this portion of our query. You'll see if we scroll down through here that some of the postal codes are characters, so they're not just numeric. What happened is, while trying to evaluate this, SQL Server tried to convert this numeric data type into a string data type, but when it got to this, it wasn't able to convert V6B3P7 to a number so that it could compare it to this number. I can fix this by just typing these as actual strings. You can see that sometimes SQL Server will let you get away with that conversion depending on exactly what your query criteria is, but it's not always able to do so, and that can result in an error. Let's execute, and there's our results. When you query data from a table, the order that the rows come to you isn't necessarily deterministic, or at least that order isn't always useful. Deterministic means the same every time. Useful means, well, whatever useful means. In other words, the data that you get by default isn't always going to be in the order that you need it in. So the order by clause lets you specify the order in which rows are presented to you. You can specify multiple sort columns, either in ascending, which is the default, or descending order. Let's go back to SQL Server Management Studio and Query Analyzer window and use the order by clause. So the query results that we left off with include a number of different cities. Bothell, let's see who this is, Edmonds. We should have some Paris in here. There's some more Edmonds. Let's get these guys in order. Order by city. The default is to put them in ascending order, but you can put ascending if you want to explicitly have it there. I'm not going to bother. Let's just execute that. Now, let's see, we should have all the Bothells, and then the E's, and then all the P's for Paris. Great, so everything did come out in order. Once we did that, we could say, you know what, now let's also put them in order by address line 1. So it's going to sort first by city, and then within the cities, it should put the address line 1 in order. So if I just look at this result set before I run the query, I should see 1970 appear before 7484, which should be before 9833, which now it's not. So let's execute our revised query. And it looks like everything did line up in address line order. Let's put that into descending order, though. And this is sometimes it's a little easier to read if you stick a little space in here. SQL Server is not too crazy picky about spaces. So let's see, that should be city in ascending order, and then address line in descending order once it's sorted by city. Execute. So we've still got the cities in ascending order. Bothell is first. But now we've got the larger values, the end of the alphabet, if you will, at the beginning of the result set. If I scroll all through the Bothells and get to the E's, you can see it starts over again with the addresses. And then if we go down to the end of the E's, we then kick right in and start reverse sort of the Paris addresses. By default, the columns in your result sets are named whatever they are in the original table schema. That might not always be what you want, so you can rename the columns with aliases. Now, you're not actually changing the name of the column in the table. You're merely changing the column name that's presented to you in your result set. We should also take a look at how to refer to names that might contain characters that SQL Server considers illegal. And this is probably a good time to look at SQL Server's fully qualified naming syntax, as well as the shorter notation that you can get away with and save your fingers a little bit of effort. We'll go back to SQL Server Management Studio and the Query Analyzer window and revisit some of our prior queries. This time we'll add column aliases and discuss some of SQL Server's naming rules. Let's continue to modify this query. I'm going to go back and put in some specific columns. So let's grab address line 1, and let's grab city, and let's grab postal code. So when I run that, you can see that the columns in my results are named the same as the columns in the underlying table. Address line 1 kind of bugs me. In this result set, it doesn't make sense to call it address line 1 because it's the only address line I've included. So let's alias that. We'll use the as keyword, and I'll put whatever it is I want this to be called. I just want it to be called address. Now, you'll notice that that took on a blue highlight, and that's because SQL Server actually recognizes that as a keyword, meaning the word address has a special programming meaning to SQL Server. Whenever that happens, you kind of run a risk. I'm guessing if I hit run, this will probably work because the keyword address doesn't make sense here. SQL Server isn't looking for it in the column list as a keyword, so it lets it go. It's always safer just to put that in square brackets. You'll notice that now it isn't highlighted in blue. It looks just like all the other column heads. So I'm kind of explicitly telling SQL Server, look, this doesn't have any special meaning. I just want you to treat it as the literal ADDRESS. If I run this again, you'll notice that my result sets don't include the square brackets. Those are just a form of notation. I have not renamed the column in the actual table. That's over here. If we refresh this column list from the actual table, address line 1 is still address line 1. I haven't added anything to the table. I've just changed the way this is presented to me in my result sets. Now, SQL Server does have a fully qualified naming syntax. We've been using the shortened version. Because I'm using the AdventureWorks database, I don't have to tell it what database I'm using, but there is a fully qualified syntax. Let's see if I'll retype the table name using that fully qualified syntax. It would start with server name, so that would usually be localhost / SQL Express, and it's really rare to see people type the server name. I mean, you've connected to the server, but it isn't that uncommon to specify the database first, and then the name of the table you're after. So in my case, this would be person.address. And that's kind of a more fully qualified naming convention. It's also allowable to put the user who owns it. And we'll talk more about ownership later and where that actually fits into the naming syntax. But for right now, let's just keep it at that. All the red goes away, so that means I've typed it correctly. And my query still executes. So keep in mind the little trick with the square brackets. Anytime you've got a name of an object that might overlap with a SQL command or might even contain a character that's illegal to SQL Server, those square brackets are the way to get started with that. And keep in mind that there is a fully qualified naming syntax for all of these different database objects. I could use that same fully qualified syntax for the column headers as well. The reason you don't, the reason people tend to shortcut this a little bit, is simply to make the query a little bit easier to read. You can imagine that if every single one of these was fully spelled out, it would kind of start to be a little bit of a hassle. It would just make the query a lot uglier to look at, and so that's why we have the shorter version that we can get away with. If you were asked to take a bunch of people in a room and put them in order by their names, how long would it take you? Think about that for a second. You'd have to go to each person in the room, ask them what their name is, and then kind of try and wedge them in next to each other in the appropriate order. Would things be faster, do you think, if you had an alphabetized list of their names up front and you just needed to read down that list and call the names out and let people line up as you called them? Well, sure, it would be easier. And SQL Server works in much the same way. In SQL Server, that alphabetized list is called an index. And without an index, SQL Server has to perform something called a table scan, meaning it basically just has to scan through all the values one at a time, just as you would ask each person in the room for their name, and put them in order. Table scans are generally considered to be very inefficient, except on very, very, very tiny tables with only maybe a couple of dozen rows. This same rule applies to filtering. Imagine if you needed to go through the room and ask all the people whose last names started with an M to come up front. Well, if you had that alphabetized list, that index, you could just go straight down to the M's, call off the names that you found there, and let those people come to the front of the room. If you didn't have that index, though, you'd need to go around to every single person in the room and ask them their last name. The ones whose last name started with an M, you could then say, okay, well, go up front, but you'd be talking to a lot of people for no reason. That really demonstrates the inefficiency of a table scan. So as you write queries, think about how SQL Server will execute them, and then look at how SQL Server is executing them. That's one of the cool things that you can do with Query Analyzer. So let's go back to SQL Server Management Studio and see how it can show you the execution plan for a given query. It's always useful to think about how SQL Server would execute a query, but it's more useful to see how SQL Server actually executes a query. And it's one of the main points of value in this Query Analyzer window. Up here in the toolbar, I've got a couple of buttons. Display Estimated Execution Plan. And that's just kind of SQL Server's first guess at what it's going to do here. It says, okay, I'm going to run this select. That's not taking me any time at all. And then I have to sort. And I've got to sort a couple of different fields that you've given me here. And this is going to take 22% of my time. And then my next is going to be an index scan. So this is telling me that SQL Server actually does plan to use an index, the address line 1 index to be specific. This operation is taking 78% of the query's execution line, and it's probably doing this in order to accomplish this particular sort value. Let's run this again and display the actual execution plan. You can see here after I execute the query with that button turned on, I get a separate tab over here for the execution plan. And it looks like the actual execution plan is really close to what the estimated execution plan was. In fact, it might be exactly the same. So getting that estimated plan requires relatively little work from SQL Server. You're just asking it to, hey, go out and look and tell me what you think you would do. Sometimes that estimate can differ from the actual execution plan. So once you think you've got the estimated plan dialed in for the performance you want, it's a good idea to go ahead and run the query and look at the actual execution plan to make sure things turned out the way you estimated they would. In this lesson, we covered the basic select query, the most common foundation query that's used to retrieve information from a database table. I also showed you the where clause, which lets you filter the rows that you get back. I showed you the order by clause, which lets you sort the rows that you get back. And we talked about column aliases and SQL's naming conventions. You even got a bonus look at how to see the query execution plan right in Query Analyzer.